Our next speaker is Riccardo Bommarco. Riccardo is Professor of Agricultural Entomology at the Swedish University of Agricultural Sciences in Uppsala, Sweden. His research studies insect and plant ecology in agriculture. It explores how farming practices, land use, and climate affect biodiversity and ecosystem functions, such as crop yield, pest regulation, and pollination. He also participates in interdisciplinary research on economy and societal transformations, and co-designs sustainable cropping systems together with researchers, farmers, and stakeholders. Riccardo will present his paper on ecological innovation and redesign for pesticide-free crop protection. Please give him a very warm welcome.
Thank you. Thank you so much for inviting me here. I'm really excited about this conference, and also, so we heard in this introduction about the challenges that we face, but also I'm really was really happy to hear from our lawmakers and from policy the great support that we're getting in this redirection of agriculture that is absolutely necessary for us to reach these ambitious targets as expressed in the Green Deal and you know, even more in the idea of a pesticide-free agriculture. And how do we then achieve that? Well, I don't know, have you ever seen this one before, any of you? The integrated pest management triangle that was developed by peoples in the 50s, in the 60s, where, you know, as a result of the catastrophic, in some cases, catastrophic results of excessive insecticide use in, for instance, California and Australia. So, you know, and there is a lot of talk about IPM, of course, and if we would have implemented in the way that the founders of this framework thought of it, I think we wouldn't have had such a big problems of scratching out that pesticides at the top of the iceberg. But unfortunately, I believe that in many of our cropping systems, we've actually inverted the triangle so that we are dependent on the top, and then we have basically not managed the bottom proactively and based on biodiversity to minimize the top. So to get back to this triangular form of the management, and this is a sort of a little bit of a revamping of the IPM triangle where we also included pollinator management. We need to redesign the bottom part, that this far has basically been designed in a way that has led to an increase in pesticide use instead of a decrease. And only in cases where the top of this triangle has not been able to deal with the problems that are that has emerged from the bottom, then we have changed the bottom. So for instance, we have to have a more diverse crop rotation when we get clump root disease in oilseed rape, just as an example, because there is no pesticides that can deal with that disease. So we need to, if we're going to achieve our targets, our ambitious targets, we need to do ecological redesign. You can also call it ecological modernization or ecological innovation. So what is that then? That is based on a larger dependence on biodiversity. So we need to work with biodiversity, not replace it with inputs. We need to strengthen the ecological functions, which increase the capture and efficiency on on-farm resources. And this will also decrease the necessity of putting in stuff into the ecosystem to get the produce that we want to get out of it. We need to enhance stability. We need to think more about stability and reducing and spreading risks, and of course about the environmental impacts of the cropping systems. There will always be an environmental impacts of any cropping system that we are having. So just to give an example what that biodiversity could be, This is trials from conventionally cropped winter wheat across Europe, where we simply, in very intensive agriculture, put out these cages to exclude the predators from the cages. And within the cages, you had these aphids that were then here. The aphids were liberated from predation pressure, and this is how many they became, and this is how many aphids there were outside the cages where they were exposed to this predation. So this gap between these two bars, that's the biological control that exists in our conventional winter wheat fields today in Europe. And this is still an environment that was very tough for them. So there's great potential to enhance this kind of service. So what are then the ecological characteristics we should strive for? In general terms, what is the kind of ecology that we want in the new ecologically redesigned agriculture? Well, I think in general terms, we need ecosystems that are less disturbed. They are more diverse, and there I'm mainly primarily talking about functional biodiversity, so more functional biodiversity, where biodiversity is not only the wild animals and microorganisms and so forth that are around, but also the crop that we put into the ecosystem. That is also biodiversity. Actually, that's a key, founding part of that ecosystem, of the agro-ecosystem, is the crop itself. And wherever possible, we add perenniality in the ecosystem. We know that that makes huge positive effects on functionality. Okay, so what should we do then in practice to achieve this? Well, I mean, we should continue doing this kind of work, agronomic work, where we try to, with, like for instance here, where we seed establishment or crop establishment, test different methods and technologies, in this case together with farmers, which I always think we should work with, for instance, in this case, we test how direct sowing affects reduces the attack of a flea beetle in oilseed rape. We're also manipulating sowing time and sowing densities. We have a lot of that information for specific crops and for specific pests actually around. But what happens when a pesticide is introduced in this system? All of this is not used or forgotten. But this is what we need to work a lot with, and we need to work with farmers. Because there are farmers out there that are innovative, that are really excited about this, and they also have the knowledge. These farmers, for instance, came with their machines basically for free, drove them long times to get this trial up, and we actually saw that there was a positive effect on the pest control. So this kind of work will we need to continue and increase. But then we also need to redesign the system, and here there is a lot of different options that can be used. Yeah, I sort of forgot to say that in that triangle I had the crop field and the landscape at the bottom. There is yet another level above the crop field, which is the plant and the plant microbiome, which is also a key ecosystem within this larger ecosystem. But I'm not going to bring that up. I'm sure that other participants in this conference will bring that up, but that's also a very important part. So there are many different things we can do. Where, crop rotation, for instance, is something that we're focusing a lot on in our research now. We know well that it can have very many positive effects on pest control and weed control, and we have a trend in Sweden, at least in our cropping, for more monoculture. and less diverse ecosystems, and that has increased our dependence on pesticides and mineral fertilizers in a way that has made it more difficult for us to, that has led to that we neither have achieved our targets for reducing pesticide over time. So that's, this is many different things we can do in the field. I think a general, very important thing is to integrate crop and animal production. We have this regionalization of animal production and basically feed production in different regions, and that makes the recirculation more difficult. Another thing is that when we have animals and crop production close to each other, we can recirculate and put in the organic fertilizers to the soil instead of being dependent on the mineral fertilizers. We have also shown in recent work Riccardo Bommarco Aguilera, that this organic fertilizing enhances the communities of these natural enemies that feed on the herbivorous insect pests. So there is like a positive feedback also on crop protection from fertilizing. Furthermore, when the farmer has animals nearby or on the same farm, there is more option for a varied rotation and for growing a larger number of crops. All this said, though, it can happen that if we reduce the pesticides or take away the pesticides, there are some locations and some situations for some crops where we cannot grow that crop, basically, without a too high a risk. And that is a loss we might have to face. Let's see. Yeah, so was also mentioned by Florence, these animals that we depend upon, and also the pest itself, is mobile and moves around in the landscape and is dependent on multiple resources in the landscape across the season to survive. So when we create landscapes like this one, this is strawberry cropping in California, it becomes very, very difficult for a predator to survive. They can feed on the pest when the pest is there, but the pest is often there during a short time during the season. And the rest of the season, where does it go to eat? Where does it go to overwinter, etc.? So by creating landscapes where there is a continuity of resources for this biodiversity, we can build a strong functional diversity in the landscape. And you can do that in many different ways, as with the crop field. We can preserve and restore natural habitat. We can work with field borders. We are now having projects together with the road authorities how we can use the infrastructure habitat, which in Sweden covers 500,000 hectares, roughly, and is managed. It can be managed for biodiversity and ecosystem services. Also, the crop rotation or crop diversification itself, we show that affects these organisms positively. Again, because we are introducing biodiversity to the ecosystem in form of, for instance, of a greater range of different crops that provide resources for a greater range of different organisms. And that is, so we have so diversification emerges as a sort of general strategy and that can be done in many different ways. So it's, but what we've gone through the literature in terms of what diversification can give us, and what we find is that it strengthens overall a lot of different functions without punishing crop yields necessarily. And you see there's a lot of variation around these, so there's options here to find solutions where pest control is at this end and yields are at this end. This is where we come in to do work together with farmers and other agriculturalists. Most of these comparisons are made one by one, so one diversification, one function. There are a few that actually look at one diversification for one purpose, say improve pest control, but does that punish another function? And there are trade-offs, there are lose-lose situations, but there are also win-win situations. In this case, presented as when we strengthen one function, how does that affect crop yield? And these of course this is the space where we want to be and where we want to work. So now you feel maybe that, oh, Riccardo, now he's totally strayed away from crop protection and pesticides, but as the question here that Florence got, they are clearly interlinked, and it's really important that we have a multidimensional follow-up of when we do change these ecologies, such as in this long-term trial in Iowa in the US, where they look at, of course, the yield and the inputs in terms of herbicides here, how that decreases in this case when they diversify the rotation from a 2-year maize soy rotation to a 3- or 4-year crop rotation. You also look, but also note the use of synthetic nitrogen inputs that is creating huge problems with the drinking water and pollution in this area. And the economy, where the profit remains the same in this case. I just also want to here point at the just very fresh paper that we got accepted the other week, Nilsson et al. In Ecological Economics, where we show that Swedish farms that have a higher crop diversity also makes more money. And this is a data set with the tens of thousands of farms over 20 years. So a multidimensional follow-up is needed. Added benefits, it's that I think that there is opportunity here if we do this right, which I think we will be able to with all the competence that we have. Is that we can build long-term fertility, we can reduce dependence on fossil inputs, which we can spread the risks in face of climate change and geopolitical risks. We can shorten the vulnerable supply chains that we have today. We reduce dependence on a very, very minute number of commodity crops, and there is potential also for jobs maybe. And finally, it's going to be great fun to do this research. I mean, as an agricultural researcher, I think this is just so exciting to see the support that we get now for these kinds of ideas. And I'm sure that out there's also a lot of innovative farmers that are, want to grow and want to grow more and more diverse. Thank you.
Thank you very much, Riccardo, for this very clear presentation on redesigning crops. I think you've given some very strong arguments in favor of the solutions you're presenting. We have about 5 minutes for questions for Riccardo. Again, on either side of the room. Yes?
Thank you. Is it possible in some of the cases where you actually diversification of the crop or the environment leads to increased pest pressure, increased disease, that the diversification not only creates places for the predators to feed and auxiliaries to feed, but also reservoirs for the pathogen or pests?
Yeah, that could happen, and that we have to keep an eye on. But like, for instance, I'm like, it's not like rocket science. This is not. There's a lot of things that are not that new. We know, for instance, that increasing variation in crop rotation can hugely improve weed control. For instance, it will avoid pests that are enhanced in the soil or in the crop when you have the same resource planted over and over again. But that could happen, what you're saying, and we have to, of course, work with that.
In the field of at least pathogens, I don't know about insects, but for pathogens, we tend to ignore that aspect of their life. We think they're specialized to crops, and so it's something, part of the change of the paradigm.
Great. No. I mean, yes, absolutely. I mean, we often got that question also when we work with the semi-natural habitats and putting in, flower strips and things like that. Do we then grow a pest? That is a potential risk. What we could think about, though, is could we grow food for the predators that are not pests in these places? We could think more about the ecology of the natural enemy and the population dynamics of the natural enemy. What is the bottleneck for that enemy in terms of resources? Can we provide that resources by engineering the landscape? So I think we can think in those terms also.
Excellent. Any more questions for over here on the right? So redesigning, re-engineering, many avenues to explore.
Thanks a lot for your presentation. The approach suggested clearly requires constant adaptation, right?
Sorry, I'm not hearing you really well.
Should I put? Okay. So this approach you're suggesting, it requires constant adaptation, right? Because the ecosystem will constantly change on a landscape level, and I'm wondering what is your approach to research to actually support farmers in this constant adaptation of management strategies? What kind of research do we need? What kind of approaches? How do we have to change research to provide farmers with the knowledge and constant adaptation of knowledge to actually react to this?
Okay, so farmers are doing what you're saying every day, even in the most simple of, simplistic of cropping systems like in Iowa, where they basically grow 2 crops. The farmers are needed there to do the timing right. They know their soils, they know their place, and they will. So that knowledge, the local knowledge that they have about their situation is extremely important, and they're doing adaptive management all the time. Now, I think in comparison with how we have done it this far the green revolution kind of agriculture is more top-down, like technologies are developed, cropping systems are there, and then this information is given to the farmers that implement it. I think here we need more of a dialogue and an exchange between the farmers and the adaptive management that is done by the farmers, especially maybe the more innovative and the really good growers. The researchers go in there, can give information about the details that they don't know about, like microbiomes or the ecology of natural enemies or whatever. But we can also then take example from these farmers and see, okay, this farmer is doing something that really works here. Let's see how that works. What is the mechanisms for this? How can we, implement it in other places? How can we translate this to? How can we test it scientifically? And how can we disseminate this to other farmers in other places? How can we implement this in other locations and other countries? So I think there is this knowledge exchange needs to be more active, and there needs to be a lot of more respect and engagement in the knowledge that the farmers and agriculturalists otherwise hold, like advisors and other people that are knowledgeable about these ecosystems.
Okay, thank you very much. I'm sorry we do not have any time for any more questions, but don't hesitate to find Riccardo during lunch or the break. We can hear the enthusiasm in his voice about all the possibilities for research and for farmers for the future. Thank you very much, Riccardo.
Thank you.